Now coming to the chemical properties of carboxylic acid. I have already said you that carboxylic acid RCOOH, the general formula, it dissociates to give you that is RCOO minus and H plus ion. And RCOO minus, that is a carboxylate ion, is quite stable in nature. It is stable due to resonance. Alright, it's stable due to resonance. Already I have explained you all those things, due to which H plus ion is readily released. So if you compare with alcohol, alright, and water and phenol, you will find carboxylic acid is more acidic in nature. Alright, if you compare the acidic character of alcohol, phenol, water and carboxylic acid, you will find carboxylic acid is more acidic in nature. Alright, compared to alcohol, phenol and water. Alright, we can say that. Similarly, that is if you see, that is what you can say, the acidic nature of aromatic acid, aliphatic acids, then you will find the aliphatic acids, that is your formic acid, is much more acidic in nature. Because I said you earlier that formic acid means HCOOH. Alright, HCOOH. So what you find is here is that this hydrogen atom is neither electron donor group nor a withdrawing group, due to which acidic character is increased. Now the question is, how do we calculate the acidic character? How do we calculate? We will calculate it by the value of Ka and pKa. Alright, what is Ka? We have read it in ionic equilibria. Ka is nothing but known as acid dissociation constant. And pKa, what is that? pKa means minus of log Ka. Alright, so how to calculate Ka? First we'll see that. Alright, first we'll see that. Let us take that is any acid, RCOOH, when it reacts with water. What it will give you? RCOO minus plus H3O plus. Is that right? Now we'll calculate the value of K. K is what? Nothing but RCOO minus into concentration of H3O plus by concentration of RCOOH into concentration of water. Isn't it? Now we know that water generally is present in excess. Alright, it is in excess. Its concentration is 1 or unity. So we'll rub it this one because it is 1 or unity. And at that time, what I will be getting it? Here it is Ka. Alright, it is nothing but known as acid because it is carboxylic acid, so it is Ka. So higher is the value of Ka. Higher is the value of Ka. Stronger is the acid. Definitely. Higher is the value of Ka, stronger is the acid. This new equilibrium constant which you got it, this is known as acid dissociation constant. You studied all these things in ionic equilibrium. Alright, so it is ionization constant or acid dissociation constant of the acid, we can say that, which depends only upon temperature. Alright, which depends only upon the temperature and the particular kind of acid, so to say. As the temperature increases, we know that the acid dissociation constant increases, and it also depends upon the nature of the acid. Just like I said, formic acid, it's a very strong acid. So value of Ka is the maximum. In the series of carboxylic acid, you will find the Ka value is at the top for formic acid. Got it? Ka value is at the top for the formic acid. So formic acid is the strongest of all the acid, we can say that. Clear? So here it depends upon that how much of H3O plus ion is released. H3O plus ion or H plus ion, both are same. Rather H plus ion is not stable, hydronium ion is stable, so hence we take this. And moreover, acid, it dissolves in water to give you this hydronium ion, which is more stable in nature. The equilibrium is favored in forward direction. So if the concentration of this is more, definitely the value of Ka will be more. See, Ka is directly proportional to the concentration of H3O plus. As this concentration will be more, so Ka value will be more. So for that reason I said, higher the value of acid dissociation constant, more stronger is the acid. Higher the value of acid dissociation constant. In this way, measure the strength of the acid. Alright, as I said, more is the value of H3O plus, more will be this. So if it is a stronger acid, H3O plus, ion concentration will be more. If it is a stronger acid, like formic acid, if I said H3O plus ion concentration will be maximum, we can say that. And hence Ka value also will be maximum. For that reason I said, in the series of carboxylic acid, Ka is, the value of Ka for formic acid will be at the top. Because it's the strongest of all acid, we can say that. Got it? Followed by, in aliphatic acid, you will get followed by acetic acid, propanonic acid in this way. Got it? Now, next is what I said, it also depends upon pKa. What is pKa? pKa is minus of log Ka. So, here you listen carefully. Higher the value of Ka, stronger is the acid. But smaller is the value of pKa, stronger is the acid. The value of pKa has to be smaller. The value of pKa has to be smaller. The value of Ka has to be maximum. But the value of pKa has to be smaller. Smaller the value because pKa is minus of log Ka. Alright, so minus of log Ka means log 1 by Ka. We can say that. 1 by log Ka. We can say that. Okay? That is log 1 by Ka when we will do it. Minus log Ka means what? Log Ka to the power minus 1. So log Ka to the power minus 1 is, that is nothing but log 1 by Ka. Sorry, I said 1 by log Ka. It is log 1 by Ka. So definitely the smaller is the value of pKa, stronger is the acid. Got it? Listen, remember this particular thing. So the strength of the carboxylic acid depends upon the value of Ka and pK, where Ka should be more and pK should be less. Alright, correspondingly we can say that. So in this way, I have already told you about that how carboxylic acid is stronger. Carboxylic acid is acidic. I have told you about it because it gives carboxylate ion which is stable due to resonance, and H plus ion is readily released. Alright, and everything I have discussed with you, that in case of carboxylate ion, that is RCOO minus, I have told you this particular thing in the beginning of the chapter, that RCOO minus, this negative charge is equally distributed, so it is del minus, due to which what you find is that in case of carboxylic acid, the more electronegative atom, which is oxygen, contains a negative charge, and negative charge is equally distributed. That means it is delocalized, the negative charges. So when the charges are delocalized, that means energy is distributed, and energy is distributed, less energy is remaining in the compound, and less energy when it remains, stability increases, because lower is the energy, higher is the stability. Alright, so in case of carboxylate ion, this happens. So for that reason, the equilibrium is always favored in forward direction. Suppose if I take here carboxylic acid, RCOOH, then this reaction is going to take place, RCO minus plus H plus. So this reaction is always favored in the forward direction, because this is not only H plus ion is released, but at the same time this is also being stable, and repeatedly I am saying you, it is stable due to resonance. It is stable due to resonance, due to which the, what you can say, the acidic character increases. Alright, clear now? So in this way we can see it. Now if you ask me the bond length, you will be finding it out. It is, I remember it, for that reason I am saying you, 1.27 angstrom in both the cases. 1.27. After it shows resonance, it is 1.27 angstrom. Alright. But theoretically if you see, then what you find is that here this is showing double bond, is showing single bond. So bond length is going to differ. But actually it is not so. It is not so. Actually the bond length is the same. Because when same carbon is attached to oxygen, another oxygen, how it will differ? So in case of carboxylate ion, it is 1.27 angstrom. This carbon oxygen and this carbon oxygen. Due to which we know, we come to know that it shows resonance, so to say. Otherwise, the bond length of this will be smaller and this will be bigger. Because single bond, this is double bond. So bond length will be less and this bond length will be more. But here it is not so. Alright, in this way. So all these factors satisfies us or conveys us or tells us that carboxylate ion is stable, and it is quite stable structure, and it what you can say, releases H plus ion readily, due to which carboxylic acid is being acidic in nature. We can say that. Clear? So now you came to know that carboxylic acid is acidic. Now we'll compare the acidic character, that is when some other group or atoms is being present along with carboxylic acid. When some other groups or atoms are being present along with carboxylic acid, then how the acidic character will be affected. We will see that. How the acidic character is going to change, it is going to increase or decrease. What is going to happen now, we are going to discuss upon it. So the first is the effect of substituents on the strength of carboxylic acid. What I said, effect of substituents. Now there are two types of substituents are there. One is electron donor group, another is electron withdrawing group. Electron donor group, EDG, which is known as electron pumping group, which donates electron to the carboxylate ion, And another is electron withdrawing group. Alright, that is EWG, which withdraws electrons from carboxylate ion. Got it? So now it is very easy, you see here. Alright, see, it is COO, that is H. Now if here EWG is attached, electron withdrawing group, very simple it is, listen carefully. Now if this particular group is attached, electron withdrawing group means generally halogens are electron withdrawing, as well as the multiple bonds, they are the electron withdrawing. Okay. So it is going to withdraw electrons from carbon. Carbon as a result is going to withdraw electrons from oxygen. And as a result, oxygen is going to withdraw electrons from hydrogen. I have explained you this one. So the cleavage takes place and H plus ion is released. So the presence of electron withdrawing group increases the acidic character. Alright, which is otherwise known as minus I effect. We can say that. Now, electron donor group, let us say, is attached to the same group. We can say that. Now, it is going to donate to this particular carbon. So, electron density is going to increase. Electron density. As a result, this negative charge will be passed to this particular oxygen. Now, oxygen, will it borrow electron from hydrogen readily? Will it accept hydrogen? Will it accept electron from hydrogen readily? No. Will the cleavage takes place readily as it was taking place here? No. So hence electron donor group, electron pumping group, it gives electron to this particular carbon atom. As a result, carbon is not going to borrow electron from this oxygen, due to which the cleavage of this bond does not take place readily, and due to this reason H plus ion is not readily released. So hence electron donor group decreases the acidic character. Which are electron donor group? All single bonded derivatives like alkyl group, CH3, C2H5, C3H7, then alkoxy group, OCH3, OC2H5, amino group, hydroxyl group, they are all single bonded derivatives. They are called as electron donor group. They decrease the acidic character. And electron withdrawing group increases the acidic character. So first you need to understand that. On that basis only I said you that formic acid is stronger than acetic acid, because formic acid HCOH, but acetic acid is CH3COOH. The CH3COH is a weaker acid compared to formic acid HCOH. Why? Because CH3 group is electron donor group. It will increase electron density of this carbon atom due to plus I effect. Due to plus I effect, we can say that, and hence oxygen is not going to borrow electrons, or it is not going to accept electrons or withdraw electrons from hydrogen readily. Alright, readily I am saying this word, due to which the is that the acidic character decreases. That means in case of acetic acid, H plus ion is not readily released compared to formic acid, we can say that, and hence formic acid is a stronger acid. Right from the beginning I am saying you that formic acid is a stronger acid. For that reason, formic acid is treated as a stronger acid compared to any other acids. Similarly, as the number of carbon atom is going to increase, the plus I effect is also going to increase. So acidic character is going to decrease. Now, what does it mean? Suppose we are having 3 carbon atom here, like CH3, CH2, CH2, COOH. Alright, so this particular CH2 group is going to withdraw electrons from this, it is going to donate. Withdraw, I'm saying it is going to donate. Now this is going to donate and this is going to donate. So what we find is that here, that is the electron density in this carbon increases so much that it does not borrow further electron from oxygen. And oxygen as a result will not borrow electron from hydrogen. Alright, will not pull the electrons from the hydrogen atom. As a result, H plus ion, the cleavage will not take place and H plus ion will not be readily released. So as the number of carbon atom is increasing, plus I effect is increasing and acidic character is decreasing. So formic acid is more stronger than acetic acid, which is stronger than propanoic acid, which is stronger than butanoic acid. In this way, acidic character decreases as you come down the group. We can say that as the number of carbon atom increases, as the alkyl group goes bigger and bigger, the acidic character decreases. Not only that, when you add any other, any other particular group, so to say, clear, donor group, I mean to say, the acidic character decreases. So you know that, you have read it in the previous that is here, that is in class, in lower classes, in class 11 so to say, that it is the I effect increases in this manner, isn't it? CH3, then CH2, CH3, that is CH3, CH2, rather I should write. Then after that we can say that that is propyl. Then we can go for CH3 whole twice CH, then which is greater than CH3 whole thrice C, isn't it? I effect increases in this way, plus I effect. The plus I effect, it increases in this manner, got it? But acidic character as a result increases in the other way. This is more acidic. If this group is attached to COH, it is more acidic. If this group is attached, it is less acidic. If this group is attached, it is less acidic. If this group is attached, the least acidic. Plus I effect increases in this manner. Listen carefully. Plus I effect increases in this way. But acidic character, if I say acidic character, then the sign is going to reverse. The sign is going to get reversed. Acidic character, it increases in this manner, we can say that. So this is least acidic. This is tertiary. Alright, it is least acidic. Then iso, we can say that. Then ethyl, we can say that. Clear? So in this way, that is plus I effect increase in this manner, acidic character rather decreases, or acidic character increases in the opposite direction, as I said. Alright, so this you need to remember. So hence formic acid, I said again, I repeat, is more acidic than acetic acid, than propionic acid. Then what you can say that isobutyric acid. Then we can say that tertiary butyl acetic acid. We can say that, or what that is whatever we can say that. In this particular manner, the acidic character increases. This is about your electron donor group. Alright, the next we are going to come to electron withdrawing group.